No, didn't want to share that. Sorry, guys.
Sorry, I'll take the answers.
You up?
No, just ignore me.
Right, Dom, and everyone else. So, horizontal and vertical components. And you've already seen this a little bit anyway. But if we have a right angle triangle situation, then we can resolve that phasor F along this line here into a horizontal component equal to F times the cosine of the angle in here, and a vertical component F sine the angle. All right, and then we can find the resultant by adding vertical and horizontal components together, and you've met that before. Yep.
Yeah.
Remember? Okay. So if we take two alternating voltages given by V1 and V2, so we got 15 sine omega t, so that's this phasor here, and we've got 25 sine omega t minus pi over 6, so that's a negative angle, 25 long, pi over 6, which is equivalent to 30 degrees. Okay, this time we'll do all our angles in radians, so that you get the idea of what I'm talking about. Yeah, so drawn nose to tail, we've got V1 along a horizontal, 30 degrees downwards V2, and the resultant in between. Yeah.
Are we doing B
so
first?
we're going to find, sorry?
Are we doing B first?
They're both saying the same thing, Dom.
Yeah, yeah. It's not different methods.
Yeah, we're using the method of horizontal and vertical components here. All right. So what we've got to do is find the horizontal and vertical component of V1, horizontal and vertical component of V2, and then we can add two horizontal components together, the two vertical components together, and get the resultant. Okay?
Yeah.
How are we doing for time? 20 minutes, right. I'm going to switch to the whiteboard now. New page. Right, so we've got V1 V2 and the resultant in there. Yeah. So if we take just the V1 on its own, horizontal component is equal to I'm getting confused here. I really need this. The problem here is the menu, which has got the clear button, I keep touching with my wrist. is 25 cos 0, because there's no angle, yeah? So it's just 25.
I'm not getting the whiteboard too clear. I can't really read some of it.
Is that you, Logan?
That's Connor.
Connor?
Yeah.
How big have you got it, Connor? Is it on a phone?
No, I've got it full screen on my Mac.
Okay. It's not very clear though. What my writing's not very clear.
I'm not sure what it is, to be honest. It's a bit
Hang on, just let me try. Might be my writing.
I'm not sure if anyone's got the same problem or not.
Yeah, I've got the same problem, Connor.
Just let me clear this a minute. Right, let's try again. So we've got these two phasers, right? We've got one phaser V1 is 25 and the angle is 0 radians. Yeah?
Yeah.
So, horizontal component. Horizontal component is 25 cos 0, which is 25. Yeah, because the cosine of 0 is 1. Everybody follow that?
Yep.
Yeah. Does it look a little clearer now, Connor, or not?
Yeah, it's a bit better now, yeah.
Vertical component is 25 sine of 0, which is equal to 0, because the sine of 0 is nothing. All follow that?
Yep.
Yeah?
Yeah.
Yep.
Then we got this other phaser. I'm going to deal with them separately, I think is the easiest way. That is downwards pi over 6 radians. Yeah. And the length of it is 25. Oh, this one's 15. That's the other one that's 25. Somebody else writing on my screen.
Who's green?
Who's green? Can you stop it, please? Right. So this one, horizontal component, H2, is 25 cos of pi over 6. Yeah. And vertical 2 is 25 sine pi over 6. All right. So therefore, the resultant has the horizontal resultant is equal to 15, that's over here, plus 25 cosine of pi over 6. and that is 36.65 volts. And the vertical component is 0 plus 25 sine pi over 6, and that equals minus 12.5 volts. Yep. So what we're saying here is this resultant phasor R has a vertical component and a horizontal component, like so, of 36.65 that way and 12.5 that way, negative. Yeah. So the magnitude of the resultant is 38.72. How do we find the angle?
Do we not use the pi over 6?
Yeah. I'm just looking at the time because we got 5. We want this angle in here. Yeah. We know these two sides. We don't know R, do we? Because that's, well, yes, we do, sorry, but no, we don't know the full magnitude. So we've got an option to find this using the tangent, because the tan of that angle is the opposite over the adjacent. So rather than we have this room crash on us because we run out of time, I'll open up a new one. Okay.
Carry it over. Yeah.
Yeah, I'll carry it over. So I'll be as quick as I can. I just need to save everything. All right.
All right.
While I'm away, have a go at finding the angle and finding the length of the resultant. So you're going to want to use the tangent function to find the angle, and Pythagoras theorem you can use to find the length of the resultant. All right?
Yep.